Hello, listeners, and welcome back to the EdgeVerse Techcast, where we talk about all things NXP software, tools, and enablement. I'm your co-host, Bridgette Stone.
And this is Kyle Dando. Today, Bridgette, this is a great episode. I'm so glad you could put this together.
It's a fun one. We're bringing back one of our favorite collaborators, Eli Hughes. Eli is an embedded developer, a longtime friend of the show, and someone who spent a lot of time working with NXP platforms, Zephyr, and VS Code.
You know, our episodes last year, this is actually our first episode of 2026, we talked a lot about specific boards and SDKs, but today we're talking about something different. A lot of developers right now are experimenting with AI tools and how that works into their development flow.
And Eli's been hands-on, actually using AI to support real embedded builds, not theoretical, not buzzwords, just what works, what doesn't, and where it genuinely saves time.
So if you've been sitting around and wondered to yourself, should I even be trying these tools? Or is this useful for embedded programming? This episode might just be for you.
Eli, welcome back to the EdgeVerse Techcast.
Nice to be back and talk with you and Kyle.
So Eli, you're a hands-on developer. What got you curious enough to start experimenting with AI tools in your workflow?
So for me, it came down to time. I think a lot of people have the same problem. Well, you have a million projects going on. You have a million things you have to do and a million things you want to do. And how do you manage your time to get it all done? And none of us have $1 million personal budgets to hire people to do all the things. That's kind of where it started for me, is how can I optimize my time better so I'm doing less of the things I don't want to do to have the machines do it, and more of the things I want to, what I call the higher system level, making the stuff actually work, not tracing down an error message or a typo. That's where it kind of started a few years ago. And I can't even think now, because I'm using the AI tools so much, I can't think of the actual genesis other than the other year when something like ChatGPT was in the cultural zeitgeist. I was like anyone else. You kind of go to the website, you copy and paste, you start having fun with it. And then it got where I would just have a problem. Zephyr's a great case. Sometimes you get these obscenely long error messages that even for an expert, just going through it, I said, let me just paste that whole thing in. I don't even want to look at it today. And it just figured out the exact problem right to the line in seconds. That's where I was like, wait a minute. This is the ideal case of how do we take a large sum of text and reduce it to something much smaller that I can use? That's where it started. And probably about 6 months ago, it really accelerated because I learned some tricks that kind of went from the copy and paste for that thing to a huge time accelerator.
All right, let's spread this out a little bit. You've got a lot of good things to talk about. I know at NXP, we are doing a lot in our software organization. Let's talk a little bit about that. Where do you see AI actually fitting in the embedded workflow?
Everywhere. And I used to say that with pause. I'll use that classic tagline before I knew that one trick that no one knows you to know about.
Yeah.
Mostly because, and this might sound controversial, but I'll say it anyway, embedded is not special in terms of software. We think it is. But at the end of the day, the embedded of today was the PC development of 20 years ago, right? It was just, we're doing the same stuff. It's compilers, you generate assembly code and binaries, you load it. The only difference is we have interesting I/O, CAN bus screens and things like that. The actual software engineering process really isn't different. Everything that we're learning for all of the other software workflows really applies, but there's just a couple things I found that can help really making it work for the embedded side versus, say, front-end development on a PC.
All right. What's one quick one on embedded devices that have drivers or working with GPIOs, things like that?
Yeah, so I'll break it up into a couple of different categories. You do have your high-level application of I'll say algorithms, things where you're abstracted from the hardware, which most professional workflows, you write code in a way that you can compile for a PC or embedded, and you test it the same way. You have unit tests that work no matter where it's at. But as you drive lower, you start to run into issues where you can't unit test on a PC. I'm actually looking at, say, a board right now with the MCX-A. There are certain things like debugging a weird interlink between like USB and DMA, right? If you have some bug, like you can't abstract that completely away. Sometimes you just need the debugger, right, to do that. So that's one area. The other side is bring up. Say you get like a new board. It's the painful part of you have your fresh circuit board design with all your custom IO. You're not really writing application. Some other people may be doing that, but you've just got to verify, right? Does all your IO work as intended through the connectors, which can take a while. That's the part where I kind of figured out how to bridge that, where I was already using AI for like Python scripts and things on a PC. But once I figured out how to bridge it into that board bring up and that debugging, that's where it got extremely real to me. I mentioned this to Bridgette like last week. It was a few weeks ago that I really crossed and figured out the trick.
I don't know if we have time, but there was a little fun story you told me about converting code from a 15-year-old chip and copying, pasting, and using AI to add some functionality into new tools.
Yeah, I think we can bridge almost everything with that case, as well as the downsides of AI, the hallucinations and whatnot.
Well, the next question I was going to ask is where maybe does AI fall short for embedded developers, or where should we be careful?
Yeah, I think I'll be able to tie it all together with this kind of anecdote. So just a few weeks ago, a colleague and friend of mine who I'd been helping on a project for a long time. This has a very old LPC part, one of the first ones that had USB in it. The product's still out in the world. They've made more boards and they want to do like a firmware update. And I hadn't looked at the code base in 4 years. It was like in the middle of COVID or something. He said, hey, we need to get this fixed, but we want to finally turn on the USB controller in this thing. This was a project that we still use the old LPC Espresso build tools because it's been in production. I don't want to change it. And everyone's always in a hurry to get changes done, right? So we leave it alone. It was Sunday. He called me like, oh, God, I don't want to do this because finding the old SDK, this was before SDKs even existed as we know them now. They were old LPC zip files. I found my archive. I was looking through. I'm like, oh, I've got to take this, marry it in the project. This is at least a day of work, maybe two, by the time we not only get it to build, but do all of our testing. And so that's where I got the idea of like, I've been using it for just code gen, but I was looking at my J-Link and then I was looking at the USB port and I was like, wait a minute, I've written Python scripts to have the J-Link just program and do a bunch of things. So I took the time to write out a plan of how I would do it as if I'm just doing it as a human. We're going to write this script, download the code, evaluate it, read back. The key part I did was I was using Anthropic Claude. I'm saying, hey, Claude, look at this old LPC Espresso project. Here's the old zip files. The first thing I want you to do is make me a command line version that you can use to build the project, and don't stop until you can reproduce version 2, meaning to the byte. And it thought for about 2 minutes and it made a CMake and Ninja and it got it exact. And then I said, hey, while you're at it, make me a nice installer script so the other developer can use it. So that built up the tool set so it could compile the MCU Espresso project to be exact to what I had. Then I just laid out the plan of here is the feature I want. Take this old USB code, marry it in, blend it like this, and don't stop until it's detected in Windows. I watched it over about 15 minutes, close the loop on that plan because it could generate the code, but also get the feedback to the point where it found a clock initialization bug in the original example, as well as an error in the descriptors, because that example code was written before Windows 10 or 11 existed. So the descriptors need to change. I literally watched it download the USB specification, find to the line where it needed to be changed, and the Microsoft forum case on solving the problem. It was a total of about 20 minutes. I saw it grind. The next thing I saw, the USB came up and it was working. I was like, my God, that would have taken me hours just to do all those things, maybe a day when I'm looking through docs. That's where my mind changed about how do you really use this tool for the good and the bad. Since then, I've just been iterating on how do I do this in such a way So I can have it do those things you don't want to do because they're boring. They're not getting it to your end state of delivering that firmware. It's digging through docs and getting those little bugs worked out.
So to me, it's not hype. It's not replacing engineers. It's being helpful in your efficiency.
Yes. And the key part was, and this is where I start talking about the soft skills, because that's the part engineers don't want to talk about. I repeated this 3 more times over the next week for different projects and was just blown away. Then I thought about what's the disconnect here? What's changed? You see complaints about hallucinations, and there are general issues like that with AI. I think here's the difference. You think about you're managing a team of people and you have to delegate. Well, how do you approach delegation of tasks? You have the same problem. We have this objective, we have requirements. How do we know when we're done and how do we test? So whether it's AI or a young engineer who's wicked smart but doesn't really have context, how would you delegate the task to that person? And then how do you measure results? What I found is if you can set up your system like that, where you spend your time actually writing a test plan and you almost write it like you're going to do the steps, you kind of provide that feedback mechanism. As long as the problem is solvable and you're clear in your thinking, AI is just the tool to do the thing you were going to do anyway. It just will sit and do that in another screen while you're off working on another task. So yeah, to your point, it really is about that gain in efficiency so we can be working on the problems we need to be working on, not finding that weird little bug that is buried in documentation that's keeping you from that goal.
I like how you say if you can document a process that you can explain the criteria and the measurement, I think it's a great note-taking exercise too. How many times have we worked on a project and then 6 to 12 months later, or in this case, you're actually supporting a customer years later, and you have to relearn those steps or look through your notes. Now with these agents, you can have it very well organized and have that routine and process locked down. You can have these common tasks that you use all the time and accelerate them, right?
Yeah, and it actually gets people to do the thing you should always be doing in common software engineering practices that no one wants to do because it's labor intensive.
Yeah.
Here's the example. This is exactly how I do it right now because it makes it so easy even for little projects. The first thing I do is I have a structure where I have a requirements file. It's a text file of numbered requirements of software shall do X. I have an architecture file that those requirements are derived from, the philosophy of how things built. Then there's a test plan of to meet requirement 1, we run test 2. And the test is met when these criteria are met. All of that gets put in the source code. So when you have a new function that implements it, there's a comment there that says, hey, this function is implementing this requirement and it was tested like X, Y, or Z. That's an extremely cumbersome thing to do before AI, but that's the perfect thing that you now have a system where the AI can keep track of itself. You can have scripts that it goes and checks, and years later you come back to look, it's documented. All those typical systems engineering things that people hate of tracking down things in Word files or Excel files, it doesn't go away. The process in which you do it gets highly improved. Almost everyone can be doing proper test-driven design without the things people hate about test-driven design. It's that like tedious tracking. It's the perfect thing for a language model.
I also like where you mentioned when you have a young driven engineer, it's the same thing. They need to have all those files and all those details that you just described. To your point, why not capture it up front and then determine which of these tasks do I want my up and coming engineer to run with? And then what can we use the agents to assist us on? It's a necessary step. And then it allows you to analyze the problem or the code that you need to develop. And you're able to delegate and distribute it way, way easier with more resourcing. So it's great.
It's also nice because now what I do for something that's a complex task, I like to write. So I'll spend time writing out and develop the plan. I'll develop the plan and then I'll say, hey, take a look at this. Is there anything I have not considered? Sometimes it generates something that's terrible, but most of the times it looks at the plan from angles you didn't. It's just like talking to your colleague. And then what I'll do is I'll just clear its context and do it again. I'll say, look at the plan. Almost in every case, whether it's the code side of it or the planning side, it helps you focus those thoughts where the old adage of if you give me 8 hours to chop down a tree, I'm going to spend 7 of those sharpening the axe. Spending that time with those planning documents, having that as the guide works wonders for humans and machine. I find it makes things just go so much faster. I'll be able to do so much more because you have a lot of things running in parallel that you couldn't before.
All right, so why don't we jump into how this applies to things that we've talked about in the past, which is Zephyr and Visual Studio Code. How have you actually used AI in both Visual Studio Code, the environment, and Zephyr, the project and the software?
But I can attack both of those in the same response. Zephyr is actually really advantageous for AI because it's open, it's well documented everywhere. There's lots of reference and it's very well structured. When you look at a Zephyr app, they all kind of look the same, which is awesome for the models. How I use it, outside of learning Zephyr, which that takes some time for everyone, a lot of times when I help people, the biggest challenge is you get to hello world, but now you're trying to merge together samples. You maybe want to do the USB thing with the Ethernet thing. Sometimes there aren't samples for your board, but you can use other boards. You'll spend sometimes hours trying to get device tree and kconfig, the magic settings, right, for all of them. You could be sitting in VS Code. You kind of know the samples you want to use. That's the perfect thing for the LLM, saying, hey, here's my application. Here in the Zephyr tree are these 4 samples that we need these pieces from each. Let's put together a plan of how we can get this device tree correct for my board. I've done this several times now, and every complaint that people had about Zephyr before almost instantly evaporates. You have this wicked smart machine that can contextually look and build, because Zephyr, the way you build for every platform is the same. It can be in the loop. It doesn't stop until you say the build must run. Then you can bring in the loop of the J-link and the MCU link to get the feedback. Because everything's so standardized in Zephyr, it's like there's guardrails for the tool to help. That's the first thing I think about VS Code and Zephyr. That's exactly how I've been using it. The second, which was the other kind of pain point that I help customers with, is you develop on an EVK or the Freedom board, but eventually you want to get to a custom board, right? You'll play around with the device tree and the overlays, but making a custom board is not hard, but it's tedious. You got to copy paste. You got to get all the names correct. There's like 20 files. I now just use the LLM saying, here is the Itemx RT EVK. I have a custom board. Make me the custom board, except call it Eli's Mega Ray Gun board or whatever you want to call it. And then I merged it in with the pin config tool, which generates those MEX files. It generates now the DTSI for you. It can take all those pieces of information and put them together. And it goes from like hours literally to like minutes that you have something working.
That's great.
So I'm like super bullish on all of this. And I think from the XP perspective, it's been doing a really good job with all the tools between things like the pin config tool and the clocks tool and the plugins and the Zephyr support. Everything's open and documented in such a way that these LLMs and these new tools can take advantage of that just to accelerate even more.
Eli, this has been such a treat, and I'm so thankful that you were here today to share these stories. And before we wrap up, for embedded developers who are curious but maybe a little hesitant, what's your practical advice? Where should they start? How should they validate? What mindset should they bring?
The mindset to bring is the same one as you're teaching someone for the first time of how to do something, and pick the simplest possible thing. Close the loop on, hey, I've got a project that won't compile. Try to get it to do a loop where it compiles. Then you keep extending it, extend that boundary, get it to download the code for you. Then get it to take a measurement of some sort, whether it's reading a serial port or something similar. You just take baby steps and you just treat it like that young engineer who you're training who's never done it before. Then you build up these like skills that AI can use, can just be in the loop. To this point, like I have now done bring up on everything from CAN bus, Bluetooth, serial ports, USB, where I've had the AI in the loop. And then the PC is actually able to measure all those things with other test equipment to do all this bring up. And boy, does it save time. Then you can really get your hands dirty, putting the elbow grease to get your application. It removes all that, I'll call it that slog of just bring up and getting to that point.
Well, Eli, this has been such a refreshing take. Real tools, increased efficiency, and your real stories and experience. We appreciate you being here and sharing that with us.
All right, anytime.
Yeah, and from the stories you shared and what you've been working on, similar to what I've heard from our own embedded developers, is that it's not replacing people. I mean, we are so busy. Everybody is trying to accomplish more with less. Everybody's jobs have pretty much been outlined and defined. I think what AI is allowing people to do is, Bridgette, you said, be more efficient. It's leveraging these models to do those routine things that you don't need to necessarily spend as much time on, so you can spend time on being creative and working on the harder problems. Hopefully our listeners learn a lot and they can look into some of the things you've done to improve their own jobs.
I'm going to be probably after the new year here and I eat all my holiday cookies and going to get back to work. I'm going to be posting on LinkedIn of just some more anecdotes. I'm going to be playing around with it. I actually had a little holiday project. I actually used AI to get done really quick that I'll be posting about shortly.
Well, give Claude a break, Eli. It sounds like you're really working.
It's 24/7, right? But it's so exciting because there's all these things I've wanted to do that I don't have the budget to pay for an engineer on all the time. And maybe it's not even worth something, but it's worth it to me to have some extra tools. I can have this machine making me those really custom things for my workflow. And it's really been eye-opening. I would really encourage anyone to think of it that way too. It's like the assistant you've always wanted.
Yeah. And to our listeners, if you're experimenting with AI in your embedded projects, we'd love to hear how you're doing it and what you're finding as far as efficiency and some tips and tricks. Drop it in the comment section. And as always, thanks for tuning in, spending some time with us, and we'll see you next time on the EdgeVerse Techcast.